Guys, please, in the keyboard, type a Y if you can hear me. N. Type an N if you can't, but that wouldn't make any sense. Okay. Emma says Y. Good. Okay. Then let's get started. It looks like we've got how many people? 11. I'm going to wait like one more minute for a few more people to join. If you have any specific questions that you want me to go over, you can just type it in the box, or you can send it directly to me, and I'll make sure that I take note of it and that we go over that. So again, just going to wait a couple more minutes. We've got a good amount of people joining. People are still waiting, so so what I've just typed in is essentially what is going to be on the short response tomorrow. The multiple choice, so I want to just get through these four main topics, and then we'll work out the multiple choice after. So I know this is recording, so some people may find this useful if you can't tune in right now. Okay. So let's do an exponent rules problem then. This is not good. I suggest that if you're watching this, that you do these problems with me as I'm doing them. No, Christian, there's not a black screen. Do you guys see a white board with me writing on it? Press Y if you do. Okay, I'm not sure where you are, Christian. I think that like if you're on a phone, Nahian, you can't see anything. That's. Are you guys on a phone? You're not on a phone. You're on a computer. I'm not sure uh, what is going on. Laptop. Something like join. One sec. You should be able to rejoin if you exit. Christian just emailed me. I'm not sure what that's about. I'm not sure what's going on if you guys only have a black screen, really not. But you know, we're gonna just try to make this work, and I'll see if I can post this video somewhere anyway. Okay, so again, I highly suggest that you work these problems out with me. So what we're going to do in this situation is getting started right now. Let's see. We first distribute the negative. That's always going to be our first move. And it's exponentiation through multiplication. Remember, EMA. So I'm allowed to distribute this. And we're going to rewrite this as 3 to the negative fifth, k to the negative 15, and v to the negative 10th, all over, we do this one step at a time, 4k7 v 5. Okay, from here, we're going to just deal with the stuff. We only have negatives in the numerator, so that's nice. We only have to deal with the negatives in the numerator. So everything in the numerator has a negative exponent, so all this stuff has to be moved to the denominator. So that leaves us with 1 over 3 to the 5 times 4. K7, K15, V5, and V10. And let me see what 3 to the 5th is. So we do 3 to the 5th. Bring a calculator tomorrow. 3 to the 5th times 4 is 972. So I'll write this as 1 over 972. K7 and K15 is, add the exponents, K22. And V5 and V10 is V15. So this would be your final answer right here. Okay, give me a Y if you are good with this one and you want to move on, or you can direct message me if you have any questions about any of the steps. Okay, it seems like we're all pretty good with this. What am I drinking? None of your business. All right, moving on. So expect that as one of the problems. Video isn't working. Christian, oh my God. I don't know, try signing in from a computer, maybe. As long as the sound is, oh no, you still need to see the screen. Okay, 2, second problem. Sharing whiteboard, maybe this will change. Okay, here's a type of linear equation that you should expect to be on the exam. This one just requires some distribution. I literally pulled this right off of Delta Math. So this is going to be positive 8. So the negative 4 times the negative 2x is positive 8x. Negative 4 times positive 4 is minus 16. We still have a minus 3x here, a minus 4, and equals 25. Okay, from here we combine the like terms, like the first day of instruction, and we get 8x minus 3x is 5x. Negative 16 minus another 4 is minus 20 equals 25. We are going to add 20 to both sides. We end up with 5x equals 45. We'll divide both sides by 5. And x is going to equal 9. Okay, easy enough, guys? Give me a Y if that's easy enough. Okay, looks like we're ready to move on. Let's do a different type of linear equation one now. Let's see. Again, I really suggest that you guys work out these problems with me as I'm doing it. It's definitely going to be helpful. Okay, so this is problem 3. One thing that you could do right away in this one is you could distribute the 1/2 through like this, but that could get annoying. The way that I taught you guys in class that I suggest that you do it is to just rewrite everything as a fraction. And this is 1 times 5x plus 6 all over 2. And of course, we don't have to have the 1 there, but we'll leave it there. Now we want to make all of the denominators the same. The least common multiple of 1 and 2 is 2. So we're going to multiply just this by 2 over 2. Okay? That gives us 18 over 2 equals 5x plus 6 over 2. I don't need to have those parentheses at this point. Doesn't matter if I keep them, it really doesn't. Now that we have these same parentheses, we're just going to get rid of the 2's down here. Okay, and we're left with 18 equals 5x plus 6. So getting rid of those fractions right away because they're kind of bothersome. Subtract 6 from both sides. And we get that 12 equals 5x. And dividing both sides by 5, we get x equals 5/12. And that's just our answer. It's nothing neat and tidy looking. Okay, guys, give me a Y if you're good with this one. All right, moving on. So know how to do that. Again, you could have distributed this, the 1/2. I'm up here now. You could have distributed that, but then you would have had 5/2, and you would have had 6/2, and you would have just had to deal with more fractions. So just understand that 1/2 times something is the same as that thing divided by 2. That is to say, if I have, this is key, if I have 1/2 times, I don't know, a smiley face, that's the same as the smiley face divided by 2. If you have 1/3 of, I don't know, a whole bunch of stuff, that's the same as all of this stuff divided by 3. Okay? Okay, get to your next problem in 1. So what is the remainder when 2x cubed minus 5x plus 4, 2x cubed x plus 4. Send me a direct message and tell me how you would do this problem. So instead of clicking everyone, you would just click on Mr. Fox. Okay, so far 3 correct answers, 4 correct answers. Okay, let's stop there. So the easiest way to do this is to use the remainder theorem. Now, if you were going to do polynomial long division, you would, as a student pointed out, have to use a placeholder if you were going to use polynomial long division. Minus 5x. And polynomial long division is going to give us the remainder, but it's so much easier just to plug in, instead of -1, to just plug in +1 into 2 times 1 to the third minus 5 times 1 plus 4, and just use the remainder theorem. So this is just 2 minus 5 plus 4. Let's see, who are they going to associate with? So it's going to be 2 minus 1. So the remainder is going to equal 1. So you don't even have to do polynomial long division for tomorrow's test. So you would substitute the opposite, +1. What's for dinner? Ran, what's for dinner? Pizza? Is that part of the thing? Okay, so would anyone like to see how to do the polynomial long division in this, as long as we're at it? Type in a Y if you'd like me to do that. Okay. What should I have for dinner, guys? Here are my options. This. All right, type in a 1 if I should have steak and black beans quesadillas. Type in a 2 if I should have brown butter gnocchi. Oh, that looks good. Please type in 2. Type in a 3 if I should have French onion soup burgers. Don't type in a 3, I'll fail you. We're not having, there's no truffle pizza involved. It looks like everyone's typing 2s. They're all typing 2s. You don't need to see. They're all it's all 2s. You don't have to see anything. Okay, 2s. Thank you, Danuta. Okay. Just going to erase all of this stuff and do this one now using polynomial long division. Wait, what did I choose? Quesadillas or gnocchi? Gnocchi. All right. All right, polynomial long division. Here we go. Oh, Liz says all of the above. You want to make a few of them?
Sure.
Liz, that's mean. My wife works all day, and now you want her to come home and... Wife, can you fill up the water, though? No, I'm kidding. I'll be right back. Okay. Mystery liquid is water. Christian, why do you keep typing so many things? Just like relax. Michael, no, don't stream Fortnite. Please, just leave it. All right, here we go. Polynomial long division. You start with just the x. You say, well, what does x need to multiply up here to make it look like a 2x to the third? Well, it needs to have a 2 and an x squared. And then you distribute this over. And you know you did it right if after you distribute it, you get 2x to the third. You also distribute it to this, so this becomes minus 2x squared. Just like in regular long division, you subtract the entire thing. Subtraction means that you distribute this negative through, so you wind up actually just changing the signs. This becomes a negative, and this actually becomes a positive. These cancel, and now we are left with positive 2x squared, and then we bring down the minus 5x. Okay. Now we do the same thing. We say the x over here, what do we need to multiply it by to make it look like a 2x squared? Well, it needs to look like have a 2. And we need an extra x in there. We distribute this over, get 2x squared. We distribute this over to the 1 to get a minus 2x, just a minus 2x. We subtract the whole thing, and subtracting the entire thing means we just change the signs and add, and this gives us a negative 3x. Bring down the positive 4, and rinse and repeat. Over here, what do we need to multiply x by to make it look like a negative 3x? So that's a minus 3. Goes on the top. Minus 3x comes down because of this distribution that we're doing. And then negative 3 times negative 1 is plus 3. We subtract the whole thing, which means that we just change the signs and add them. And recall from before that our remainder was 1 when we did the polynomial remainder theorem. If we had to write this thing as an actual answer, you would do plus 1 over x minus 1. Okay, give me a Y on the chat if you want to move on to the next problem. Otherwise, ask your questions. You don't have to ask them directly to the group. You can ask them directly to me. Okay, good. Moving on. Let's see, I had something else written. Okay, let me ask you guys this, and you can direct message me the answer. If, let's say, f of x equaled x to the third plus 2x plus 6, and f of 3 equaled 0, what can you say about x minus 3? So remember, it's short response, so you're going to have to put an answer. So Ariana, you got it right. I'm not sure, Nahian, what that means. 0 times anything will give you 0. Is it 0 is what 0, Nick? X minus 3 is 0? Okay, and the correct answer is that x minus 3 is a factor because f of 3 equals 0 by the remainder theorem. It is a factor. F of 3, we're going to discuss function notation more. All this means is plug in or substitute into the, that's all that means. So take a screenshot of this if you need to. But f of 3, all that means is if you plug in 3 into the equation, you get 0. So what can you say about x minus 3? Well, if you plugged in positive 3 into the equation and got 0, then x minus 3 would be a factor. So this is just a fancy question to try to get you guys to think. I won't have time to do another polynomial long division, but I just highly suggest you just look it up on YouTube. Okay, moving on. Any questions on this? Write N if no questions. Ask me a question if you have a question. All right, let's do a multiplication problem. Let's say we had 2x plus 2 times x minus 1 times x plus 3. Okay, in order to multiply this out, we're going to choose two of these binomials to work with for loss of generality, for basically for no reason. I'm just going to choose the left two. I'm going to use the FOIL method. So I'm going to do 2x times x. They give me 2x squared. I'll do 2x times negative 1 to get minus 2x. 2 times x to give me 2x. And 2 times negative 1 to give me minus 2. This whole thing times this. We combine like terms over here. The minus 2x and the positive 2x actually cancel. So we're just left with 2x squared minus 2 times x plus 3. That doesn't usually happen. Now we just do FOIL again, or we can do double distribution, which would be 2x squared minus 2 times x plus 2x squared minus 2 times 3. Yeah, Liz, I have calculators. You'll just make sure that you bring your ID. Double distribution works like this. You can distribute from the right. And this will give us 2x cubed minus 2x plus 6x squared minus 6. We combine, that's it. This isn't in standard form, so we write it in standard form as 2x cubed plus 6x squared minus 2x minus 6. Time left, 30 minutes. Okay. All right. Write a Y if you're good with multiplying binomials. Okay, guys, the delta math has all this stuff. I'm like mostly pulling problems from delta math. Only a couple that I made up. Okay, moving on. Okay, the idea for this is just to factor it. Send me a direct message. Tell me what type of factoring that you would use, which method. So these are really the types that we have, right? GCF dots, trinomial, grouping, right? It's a trinomial, guys. It's not dots. Please know what DOTS stands for. This stands for difference of two squares. Two, it's not two things. GCF is always an option, but there is no GCF in this situation between 1, 2, and 24. It's a trinomial. If we factor the trinomial, you can use the X game to do that. Okay, the X game like this. Multiply to negative 24. Add to negative 2. Look at factors of 24. Let's see, we've got 1 and 24. Let's see, 2 and 12. 6 and 4. This is going to be it, 6 and 4. Let's see, we draw the bubbles. XX. We drop down the sign. We multiply these signs. And it is a minus 2x, so this is going to be a minus 6 here, and a positive 4, and you're done. Okay, give me one of those, if or just a y if you guys are good with this one. I can't stress this enough. This stuff is on Delta Math. And you can always send me a direct message if you have a specific question. Okay, I'm just going to do one more factoring one. And this is clearly a trinomial because it has 3 terms. It's not an AC method because this is a 1 out here. So we just do x, we drop in this negative, we multiply the negative by the positive to get a negative. Say what two numbers multiply to 18 and add to negative 9. I'm going to look at factors of 18. 1 and 18, 2 and 9, that's not going to do it. 3 and 6, this will do it, because 6 plus 3. So 6 and 3, and we're finished. Okay, gonna stop here and take a break for a minute. This is really all that you need to know for tomorrow's portion of the IA, which is the short response. So take your time right now, either send a main message to the chat or send me a direct message if you want me to do anything else or go over anything else. I'm getting people want to go over dots. I'm writing this stuff down, so send me messages. So other factoring methods, still getting some polynomial long division, fractional linear equations. All right, let me pull up the IA right now and see what's on the multiple choice. So for tomorrow, you guys are good. The multiple choice, let me pull it up. Okay, let's take a look at a different factoring technique. Let's say that we have plus minus 6 squared minus. Okay, here's a good problem. 3x squared plus 15x minus 18. What factoring technique should I use? Should I use GCF? Is this an AC method? Is this dots? Is this AC also is called headphones? So everyone's saying AC. Nobody's saying dots. Okay. You guys are all brainwashed because you were paying attention in today's class. You don't use AC method, you try GCF first. What is the GCF between 3, 15, and 18? Write it in the comment box. Yeah, 3. Exactly. So we can rewrite this as 3 times x squared plus 5x minus 6. Okay? Now we use trinomial. So 3 times, let's see, x plus minus and 6 and 1. So this is your answer right here. If you did the AC method, you'd wind up getting the same thing. It would just take you longer and you'd have to factor out a 3 and then you probably wouldn't be sure of your answer. So I would definitely make a special note that you know how to do this one. Hint, hint, hint. Okay, screenshot right now. Do whatever you need to do. This is a good problem. And when I say good, I mean on the IA. Okay, moving on. Just give me a why if you understand why we use GCF in that situation. Okay. And we'll do more of those problems. Remember, the multiple choice of the IAs isn't till Tuesday, so we're going to do a whole factoring review. We'll probably do another carnival on like Monday or something, just to lighten things up. Let's try this. Okay, we have choices to factor. GCF, dots. It cannot be dots because there's not two terms. Trinomial, which is the AC method is also for trinomial. It can't be because it's not three terms. So in this situation, we're going to use grouping. Well, first we're going to check if there's a GCF. There is no GCF between the 1 in front of x cubed, the 3, the 4, and the negative 12. So we're just going to group this thing like so. Again, I like to put the parentheses around the negative so I know to factor out a negative. Now we do the GCF of this bubble, which is x squared times x plus 3, and we get minus 4 times x plus 3, and it's x plus 3 times x squared minus 4, and now we have to think, are we done? Well, this can't be factored any further. This can be factored further. This can be factored using difference of two squares, because this is a difference of two squares. So this guy right here, we're going to break down even more. So he's going to be x plus 2, right, because we square root him. X plus 2, x minus 2, and he doesn't change, the x plus 3. Okay, give me a Y if you understand this problem. And N if you don't understand it. Okay, mostly pretty good. Okay, here's a good one. Let's factor 81 minus z squared. Should I use GCF? Type it in. Dots. Trinomial. Trinomial AC, or grouping. Correct, it is dots. These are two perfect squares, and this is the difference. So we square root this, write the two bubbles, and we get 9 plus z, 9 minus z. Trinomial. Okay, new problem. Let's say that we had 2xy to the third times, I don't know, maybe xy to the fourth. Remember, E, M, A. So we're going to distribute this through first because exponentiation over multiplication will distribute this as well. And we rewrite as 2 to the third, x to the third, y to the third. We rewrite this as x to the fourth, y to the fourth. Now we can simplify 2 to the third to 8. We've got an x to the third and an x to the fourth. Use the addition rule. It's x to the 7. And a y to the third, y to the 4 is y to the 7. So that's your solution for that. Okay, let's say that we wanted to know the value of 4 to the negative 2. We'll just recall x to the negative 2 is equal to 1 over x to the positive 2. So this is going to be equal to 1 over 4 to the positive 2, which is 1 over 16. As you're going on, just send me questions if you guys have them. There's like some funny emojis, like coffee, little hand raised guy. Do that too. Yes, there are going to be exponent rule questions. There's going to be one tomorrow, like that's very similar to the ones that are on Delta Math. This type of question will be on the multiple choice, I can guarantee that. The previous one that I did will be on there. Let's see. 7 questions for tomorrow. Let's say that I had, I don't know, x plus 4 squared plus 3 2x minus 1 squared minus 6. Correct, lady. X to the 0 equals 1. Just a note. All right, the way that you would do this is you would essentially do PEMDAS. So we're going to work out the parentheses first. So we're going to square the x plus 4. This becomes x plus 4 times x plus 4 plus 3 times, we're going to square this, meaning multiply it by itself 2 times. And then subtract 6 from the end. Now I'm not going to do all the math behind this, but the idea is to not do this. Right? Do not do this. A, exponents do not distribute over addition. So if you see a problem that looks like this, don't freak out. Just do exactly what it tells you to do. And what I mean by that is the exponent tells you to multiply it by it twice. This exponent tells you to multiply it by itself twice. Just do exactly what the math tells you to do. Yeah, Nahian. Then you would multiply the binomials after that. I just don't really feel like doing it. You'd get x to the x squared plus 8x plus 16. You could distribute this in if you want, or you can multiply the binomials first. That's how that works. Let's see. 6x cubed plus 1x. Okay, I'll do, Tony, listen up. Polynomial long division. So we have 6x cubed plus 5x minus 8 divided by x minus 2. Okay? It's missing something. It's missing an x squared term, so we need to rewrite this as plus 0x squared plus 5x and then minus 8 and divided by x minus 2. Okay, give me 1 sec, guys. So we've got about 10, 12 minutes left. This might be the last question that we do. We'll do a review probably on Monday, though. Okay, I'm going to do this one like slightly different because some people aren't fully grasping this. So maybe if I show it in a different way, it'll make more sense. So x minus 3. So our goal here is to divide essentially the x into everything over here. So I'm going to show my work like on this side over here. So I'm going to divide 6x to the third by x. And 6x to the third divided by x gives me 6x squared. So that's what I'm going to put on top. That's a different way of looking at it. 6x squared. From there, I distribute the 6x squared to the x, and that will give me 6x to the third. I also distribute it to this negative 3, and that gives me minus 18x squared. Okay, I subtract the entire binomial, and when you subtract, you distribute the signs through, which means that this is going to be minus 6x cubed plus 18x squared. So the signs flip. Okay, the signs flip and then you add them. The signs flip for this reason. And now you get positive 18x squared here. You bring down the next term, which is plus 5x. Okay, and then essentially we restart the process or the algorithm. Now, I say to myself, what do I need to do, or how many times does x divide into 18x squared? So you have 18x squared. You can actually do the division off to the side. Divided by x, well, that just equals 18x, because you would use the subtraction property like that. So we're going to put a plus 18x here. Then we distribute that through, and we get 18x squared. Let's see, negative 3 times 18 is negative 54x. Right, because we distributed that here. You subtract the whole thing, which means you just change the signs and then add. So this becomes 59x. Oh, this whole thing was supposed to be x minus 2, by the way, but I'm not sure that matters. Okay, minus 8. Now we divide 59x divided by that x term, and it's just 59, so we put plus 59. Multiply that through, you get 59x minus whatever 59 times negative 3 is, 177. Change the signs and add, so it's 177 minus 8, and we get a remainder of 169. So guys, tell me, write a y or an n. Is this a factor? Remainder of 169. That is x minus 3 a factor of the larger polynomial? Yes, I'll grade the short response how I graded the other exam. Correct. It is not because there is a remainder. You need to know the degree of a polynomial and how to write it in standard form. Let's see. I don't have anything else to go over, so I'll open the floor up now for questions. You guys can type in questions. If not, then I'm just going to end the session. Exponent rules. Sure, I'll do an exponent rules one. So say I've got, let me just make one up, 2x to the negative second, y to the third, all to the second, over, I don't know, y to the negative fourth. What you're going to do is distribute this through first, which gives us 2 to the second, x to the negative fourth, y to the sixth, over y to the negative fourth. At this point, we pick either the numerator or the denominator, and we decide to move anything that has a negative exponent from either the numerator to the denominator. So what I mean by that is I'm going to rewrite this as 2 squared y to the sixth over y to the negative fourth, and then that x to the negative 4, if we bring it into the denominator, it becomes x to the positive 4. Now we still have a negative exponent here, so we need to deal with that. We're going to move this from the denominator into the numerator. So we have 2 squared y to the sixth, y to the positive 4 over x to the fourth. And finally, we simplify this whole thing. 2 to the second is 4. Y to the sixth times y to the fourth is y to the 10th. You add, remember EMA, over x to the fourth. Okay, EMA. That means if you're multiplying variables, you add the exponents. If you're raising a variable to another exponent, like here, then you multiply them. All right, give me I'll open the floor to any other questions at this point too. You're welcome, Nahian. Yeah, Aaron, that's a good question. An overview of the topics that short response will cover. So, George, if you have a negative exponent like this, x to the negative fourth, this is defined as 1 over x to the fourth. If you have something like 1 over x to the negative fourth, that's defined as x to the positive 4. So what you do is you just move it from numerator to denominator or vice versa, and you just change the sign of the exponent. All right, so I've got less than 4 minutes left, less than 5 minutes left, so I'm going to answer Aaron's question and give you guys a overview of what's going to be on there. Let's see. Let me pull it up. So this is short response. We're going to have exponent rules, And it's going to be like a, kind of complicated one, like we just did. Fraction is, we're going to have linear equations. You're going to have distribution, and there will be a fraction. You'll have multiplying binomials. So something like x plus 2, x minus 4, 2x. So probably something like that, where there's like 3 binomials. And you're also going to have to know how to do something like this. If you had x to the third minus 2x squared minus 8 times x plus 2, because this is eventually what you're going to kind of get. Right? In order to do this, you need to know how to do this. Let's see. We'll have remainder theorem. Is it a factor? So remainder theorem, if f of a equals 0, then x minus a is a factor. Know this. Screenshot that. Do whatever you need to. And you're going to have to factor that's it. These are the things that are on tomorrow's exam. These five things. Okay, give me a Y if you're good. Otherwise, ask me a question and I'll answer it with the couple of minutes that I have left. All right, I'll see you guys tomorrow. I'm sure I'll do fine on the exam. Just study, do the delta math problems. Do the delta math problems. That's Danuta, exponent rules and linear equations. I don't have time to repeat them. This session ends in a little bit, in like a minute, but it's written right here. Exponent rules and linear equations.